Hello friends. Now let's get to details about various different categories of signals we know and their differences. So let's begin our discussion with the first category. That's a type of signals that's either continuous or discrete in time. So here the continuous time we represent as x of t, and here we have all values of t possible in use, whereas in a discrete time we represent the signal as x of n, where the n is the multiple of sampling time. N is equal to 1 means the first sample, n equal to 2 is the second sample, n equal to 3 third sample. So here we are finding the value of the signal at an instant after every sampling time. So here this image shows the first one is a continuous time signal x of t, and if that is multiplied with impulses, then we do get different magnitudes of impulses. So at this instant the value was so much, at this instant the value was so much, at this instant the value was so much, and so on. So that is the discrete version of the signal. Same another example. So that's a continuous domain and that's a discrete domain. At discrete domain, if you look at it, then we have the signal measured only at a particular instance, that is a integral multiple of sample times, whereas in continuous domain a signal is available at every instant. It can be every second, can be every minute, and in every millisecond, every microsecond, every nanosecond, every picosecond. So that way you can go down to any way, and you feel and you find that there will be a value for any time you mention. There will be one value, and that is when we say that it's a continuous time signal. So the relation between the discrete time signal and the continuous time signal is the nth value in the discrete time is n units away from the sampling time. So n into t is the time we have, and the value of x at n into t will be the nth sample we have. The examples for continuous time is simple analog audio, and digital domain discrete time is our digital recording. And the continuous time information can be converted into discrete time information through a process called sampling process. So where here we have a continuous time, continuous values input, and this is sampled at every period tp. So we just keep sampling at every period tp, and what we get is the sampled data. That's our discrete time data. So comparing two together, so continuous time system or a continuous time signal is the one which is defined at any time instant. So there is nothing like any time signal is not defined. So you talk of any time, there will be a value defined for that. So if you are talking about a interval, continuous interval between a and b, then between a and b, whatever be the value of a, whatever be the value of b, between these two points in time a and b, there are infinitely number of timestamps. That's what continuous domain is all about. And here when we are talking about continuous time, this a can go to minus infinity, b can go to plus infinity. So we can cover the whole time from minus infinity to plus infinity, and everywhere, every instant, if it's having a value, then we call it a continuous time signal. On the contrary, during look at the discrete time signal, then this signal is defined only at a certain specific values of time. Not always at given instances this value is defined, and these time instances need not be equidistant, but in practice we usually prefer to be equally spaced intervals, of course, but it can be unequal also. But only thing is, there is one value at one point in time, and the next point in time there is another value, and between two instances no values are defined. There may be value, but they are not defined in our system. So such signal we call discrete time signal. And the representation of that, the continuous time signal, conveniently represented with the differential equations, whereas discrete time signals are used through the difference equations. The continuous time signal is represented by x of t, whereas the other one is represented by x of n. The example can be speed control of DC motor using a tacho generator feedback, or sine or exponential waveforms are some examples for continuous time systems, continuous time signal. So we are trying to talk both signal system together. So a system can be a DC motor where we are measuring the speed of the DC motor and trying to vary the speed of the motor, or making it a constant, or control the speed of the DC motor as per our requirement. So for that we measure the speed of the motor using a tacho generator and give a feedback. So all this, at any instant we know DC motor will have a particular speed and all that. So this is what we talk about continuous time. But on the other side you talk about microprocessors, computer based systems, they all work in discrete time signals. So there is a clock in the microprocessor system or computer based system, and all the actions take once every clock ticks. So between two ticks of the clock nothing happens. So this is what we call a discrete time signal. So that's a basic idea behind the two modes of signals, modes of systems. One is in continuous domain, the other one is discrete domain in the timeline. So that's it for now. Thank you.